Hey guys, this is our last video for Unit 8 before Thanksgiving. Woohoo! Get excited. Okay, so in this video, we're going to learn about something called electron dot transfers, okay? We've learned that in an ionic compound, you have a metal and a non-metal, right? Well, what's the job of the metal inside of that bond? Well, it says they have to gain too many electrons, right, to fill their outer shell. So instead of gaining electrons, what they do is they lose their electrons. That keeps them stable. Well, the nonmetals inside the bonding relationship don't lose their electrons. In fact, they have so many that they want to get 8 outer electrons to fill what's known as the Octet Rule, right? Getting those 8 filled on the outer side. So this causes both atoms to be charged. The metals end up having a positive charge, so we call them cations, right? And the nonmetals have that negative charge, so we call them anions. And we've talked about all that, so all that should be review. Here's kind of a picture of what I'm talking about when I say that they're being stolen. This is one way we show them. We show them with like an arrow being moved. Here is your metal, right? Metals have low electronegativities because they don't want to hold on to their electrons. They don't have a strong hold to their electrons because they want to give it away. So here's your electron. It's being taken, and now the nonmetal, which has a high electronegativity, is now holding on to that electron. Here's another picture of what's happening. Here's sodium, and notice sodium has other electrons inside of the atom right here, okay? But we only ever focus on that outer electron. That's called the valence electron, because that's really the only one that's going to be moving around in a bonding relationship. All the other electrons on the energy levels below just kind of sit there. And now let's look at chlorine. Again, all of these electrons in chlorine, we don't really focus on them. We just look at the outer ones, okay? And there's 2 here, and there's 2 there, and 2 there, so we have 6. And then there's the last one, so we have 7 valence electrons in chlorine and 1 valence electron in sodium. And you can also get those numbers just by looking at the group where we find them, right? So chlorine kind of just really wants this electron from sodium to get 8, right? So that's exactly what happens. Do you see this little dot here? That is sodium's electron that chlorine stole. So chlorine has 8 and it's happy, but now that it has 8, its electrons and protons are kind of imbalanced. So it has that -1 charge. And sodium is also now unbalanced because it's lost its electron, so it's positively charged. And that's that attraction I was talking about. Remember how covalent, they're sharing electrons, so the electrons themselves are kind of the bond inside of a covalent bond. But in an ionic compound, there's no electrons being shared. So there's really like nothing here in the middle that's keeping them together except for the fact that both atoms are now charged. So there's this electrostatic or this like magnetic attraction that holds the two together. Okay, so that is essentially what an ionic bond is. So how do we draw that? Well, we show what are called electron dot transfers. The reason why we call them a transfer is because an electron is being completely transferred in an ionic bond. So we put the chemical for the symbol of the element surrounded by the number of valence electrons present in the outer shell. So let's do lithium fluoride. Lithium, we know, is going to be in group 1, right? So it has 1 valence electron. Here's lithium with 1. And then fluorine is going to be in group 17. So there's 7 valence electrons in fluorine. 1, 6, 7. Remember, it doesn't really matter what order you draw them in. I just like to show this little extra electron on the left because it's easier to do my transfer. And now I'm just going to switch my color. Okay, so fluorine is going to gain the 1 electron, right? So the whole structure is placed within square brackets. So you would show, here's lithium, here's fluorine, and sometimes I'll show the brackets and sometimes I won't. It really doesn't matter. But the big thing is you have to show this atom being transferred to the empty space in fluorine. See that empty space there? So now fluorine has a full 8. Lithium is happy because it's lost that outer electron. But here's the kicker. Whenever you're doing electron dot transfer, your overall charge of the compound has to be 0. Okay? And you have to show the charges on both of these atoms. So lithium is now a +1 charge because it's lost the electron. Fluorine's now a -1 charge. Do I see how these charges equal out to 0? Now my whole molecule is itself neutral. Is each individual atom neutral? No, they're charged. They're ions. But the ions equal out to be neutral. Okay. Well, let's do another example down here. Lithium oxide. Okay, I'm going to change my pen back to black. Okay. So lithium, we know, is obviously still in group 1. It hasn't changed. And oxygen is in group 16. So this may not seem quite as easy. Here's lithium with 1 dot. Here's oxygen that has 1, 2, 3, 4, 5, 6 dots, right? And it says a little 2 here by lithium. What in the world does that mean? Well, 2 means that there's 2 lithiums, okay? So I'm just going to draw my second lithium over here. Voila. And now each lithium atom is going to lose its electron to oxygen. Okay, so here's my, changing my pen color again. Lithium's atom goes here. So oxygen has 2. And then this lithium's atom goes here. So oxygen has a total of 8. So oxygen's happy. Yay, oxygen. But what's oxygen's charge now? Well, it's gained 2 electrons, so its charge is -2, right? And lithium over here has lost 1, so it's +1. And lithium over here has lost 1, so it's +1. And when I put them in little brackets, that just means these are each individual ions now. Now, is my overall charge of my compound neutral? Well, I have a +1 charge, I have a -2 charge, and I have a +1 charge. If I added all those together, it's 0. So my overall compound is neutral. But my individuals are ions. So you find your charges by how many electrons they lose or gain. And then you just make sure that your overall charge is 0. And that is it for the basic Lewis dot transfers. Okay, so now what we're going to do is just a ton of practice on this stuff. And I know it's scary because it's a lot of dots and moving them around, and maybe you've never done this before, and bonding's just kind of freaky, but I just want you to be brave. Okay, enough of that.